All right, this is it. This is the last unit that you guys have to deal with. We are going to do notes in 3 parts. So we'll do parts 1 and 2 this week, part 3 next week, and then you'll have your review for your test. It'll be a nice, simple, easy open note test for next week to finish off everything. Sorry if it's loud in my room today. I had to turn on a fan because for some reason the air is not working, but we are doing nuclear chemistry. So, nuclear chemistry is nuclear versus chemical reactions. So, there is such a thing as nuclear chemistry. So, we have nuclear reactions and chemical reactions. Chemical reactions involve valence electrons combining with one another, creating a stable electronic configuration. They are affected by changes in temperature and pressure, or changes in our so endothermic, exothermic, you'll see a change in state, you'll see a change in color, things like that. In nuclear reactions, they do not involve valence electrons, they involve the nucleus itself. They don't involve the electrons. So you think of chemical as electrons, think of nuclear as nucleus. So it occurs in atoms to gain a more stable nucleus. So this is nothing to do with pressure or temperature. There's just a creation of a reaction based on nuclei either expanding into something new or combining into something new. So first we have fission. Fission is the splitting of a large nucleus into a new substance. So it's caused by the collision of slow-moving neutron. So this is a neutron that will be slammed into the nucleus of an unstable nucleus and creates a splitting of the nucleus into a new stable nucleus of the substance. So it's caused by this neutron, and it produces two smaller nuclei and another neutron. So this releases an enormous amount of energy. So this is what happens a lot in nuclear reactors to create our nuclear energy power plants. So they take a fission, they take a neutron, shoot it into an unstable nucleus. It creates these two nuclei, and then you have a large amount of heat released and a large amount of energy released, creating steam, moving turbines, that type of thing. So fission, this is uranium 235. You see it is unstable. Once it occurs, you see how it splits into barium and kryptonium. Kryptonium 92, uranium 53 will break into these as you have your neutron keep on coming from this reaction. So it is a chain reaction in fission. And so a nuclear bomb is uncontrolled fission, which means you have such a release of energy that it is exploding outward. So this energy will break apart anything in its path. And then you have a nuclear reactor, which is controlled fission, where everything is in a controlled environment, very safe, and steam is used from this energy to create turbines to create your energy, just like it says right here. So you have your control rods, the turbine moves into, generates power, condenser gets rid of that heavy water. All right, and fusion. Fusion occurs when two small hydrogen atoms are combined. So this produces helium and neutrons. So the biggest thing that uses this is actually the sun. So the sun uses fusion to create its energy. So you see the two small hydrogen create that, and then you have your neutron coming off of it with helium. So fusion takes place only at extremely high temperatures in the millions of degrees Celsius. This happens on stars. Fusion releases far more energy than fission. So even though we have a nuclear bomb and we consider that the greatest explosion that we see on Earth, the sun is millions upon millions of the amounts of energy. So this occurs only naturally. We cannot create a fusion substance. All right, and then we'll do radiation tomorrow. That's all for today. Nice quick notes. Go ahead and look over it again if you need to. Email me if you have any questions.